Hi there, I'm Teacher Lau. Welcome to this video. In this video, we're going to talk about some basic concepts on permutation and combination. Let's look at this example. Let's say you have two pairs of sport shoes in blue and in black. You can choose either one to go for sports. Let's say you have white socks, gray socks, and black socks. So the question is, how many ways you can match your shoes and socks to go for sports? One of the ways to answer this question is by using tree diagram. We have two pairs of shoes, blue or black. When we choose the blue shoes, so we can match with three colors of socks, which is white socks, gray socks, or black socks. Same thing happens when we can choose the black shoes to match with white socks, gray socks, or black socks. Then what are the ways that we can match them? So it is blue shoes with white socks, blue shoe with gray socks, blue shoes with black socks, black shoes, white socks, black shoes, gray socks, or black shoes, black socks. Our question is, how many ways to match the shoes and socks? 6 ways, correct. We can generalize this by using the multiplication rule. The first event is choosing shoes. We have 2 ways, either blue or black shoes. The second event is by choosing socks. We have white socks, gray socks, and black socks. So 3 ways to choose the socks. How many ways to match the shoes and socks is 2 ways times 3 ways, so we get 6 ways. Therefore, the multiplication rule tells us that if the first event occurs in m ways and the second event occurs in n ways, so both events can occur in m times n ways. The multiplication rule is important for us to understand the permutation and combination later on. Now we're going to learn about permutation. Let's look at an example of permutation. Let's say you are given 4 number cards printed 5, 6, 7, and 8. Then you need to form a 3-digit number using these cards. How many 3-digit numbers can you form without repeating the numbers? Pause the video and try it out before I show you the answer. At the hundreds place, I can fill it with 5, 6, 7, or 8. So there are 4 possible ways to fill the hundreds place. For example, I can fill it with 8. To fill the tens place, since one of the number in 5, 6, 7, and 8 was chosen, so they left 3 ways to fill the tens place. For example, I can fill it with 6. Since 2 numbers are used, so there are 2 more cards left. 2 cards can be used to fill the ones place. Let's say I can fill it with 5. Therefore, by using the multiplication rule, the total ways to form a 3-digit numbers is 4 times 3 times 2 equals 24 ways. Of course, you can use the tree diagram to help you, but multiplication rule saves time. In this example, 3 cards are chosen from 4 cards to form an arrangement. Note that the arrangement is important in this case. For example, 865 is not equals to 568. This is one of the examples of permutation. We can represent the number of ways as 4p3. In short, permutation is an arrangement of a number of objects, taken some or taken all at a time. We denote permutation as NPR, where N denotes the total amount of objects, R denotes the amount of taken objects. Now we will learn about combination. Consider this example. Suppose a teacher wants to choose 2 students among 3 students to represent the school for a swimming competition. How many ways the teacher can choose the representatives? Try it out before I show you the answer. We can use tree diagram to help us in this example. For the first representative, we have 3 choices: student 1, student 2, or student 3. S1 denotes student 1. After choosing student 1, the second place can be filled with S2 or S3. So there are two ways to fill. Same goes to the other situation. Note that choosing student 1 and student 2 is same as choosing student 2 and student 1. So the arrangement or the order is not important here. Grouping the same choices. So in total, we have 3 ways of choosing 2 representatives from 3 students. In this example, 2 students are chosen from 3 students without arrangement. Note that arrangement here is not important because choosing student 1 and student 3 is same as choosing student 3 and student 1. We can represent the number of ways of choosing 2 students from 3 students as 3C2. So combination is the ways of choosing a number of objects taken some or taken all at a time. We can write the number of ways as NCR, where N denotes the total amount of objects, R denotes the amount of taken objects. From the examples just now, we understand what permutation and combinations are. Let's recap what we have learned. Permutation is related to arranging some objects, so the orders are important. Combination is related to choosing some objects, where orders are not important. This video is about some basic concepts on permutation and combination. Later on, we will learn how to use the formula for them. Stay tuned!